Major product of the following reaction is, what is the reaction? Step 1, they are doing acid hydrolysis, they are under heating conditions. Then they are going to do polymerization using oxalic acid. So when you treat this methoxy, hydroxy and acetyl compound of phenol, what you are going to get? Yes friends, there will be a cleavage of this acetyl group. Deacetylation takes place in presence of dilute HCl. Deacetylation takes place to give hydroxy, that is phenol we will get. Next, what we are treating with oxalic acid, there will be two catechol type. This is methoxy and this is catechol. 2-hydroxy orthohydroxy phenols are also known as catechols. So this catechol, upon reaction with oxalic acid, it undergoes polymerization reaction. Is there any effect on this methoxy group with dilute HCl? Dear friends, to do demethylation of this methoxy group, we need strong acids like aluminum chloride. Under this dilute HCl, they are specifying dilute HCl reaction conditions. This methoxy group is not going to cleave. This methoxy group is not going to cleave. So this deacetylation takes place and methoxy group is intact. This option is having methoxy group, other options are not having methoxy groups. Let us see this option. Is there any relation? So this is not methoxy. So this, where it is acetyl is here. No, demethylation will not go. So here it is demethylation is taking place. So the polymer is correct, but demethylation is taking place. Here also no, demethylation will not take place. So the option number 1 is correct friends. Option number 1 is correct option friends. Next, question number 7. The reaction that is not involved in the ozone layer depletion mechanism in the stratosphere is, dear friends, be careful. This kind of questions are very typical. When you do not concentrate on this not option, the reaction that is involved in the ozone layer depletion mechanism in the stratosphere is straight away simply what do you select? Chlorofluorocarbon containing compounds causes ozone layer depletion. So the option number 1 straight away you may choose. But they are asking not involved. So this option is not correct. Dichloromethane is involved in the ozone layer depletion, but they are asking not involved. So this option is not correct. Whereas this chloro compound, yes, this is also causes depletion. What about hypochlorous acid? Yes, this also causes depletion. But methane gas, there is no halogens. This is not going to not involved in the ozone layer depletion mechanism in the ozone layer. It is fact that the reaction is not involved in the ozone layer depletion mechanism in the stratosphere is methane plus ozone giving formaldehyde plus water is the reaction which is not involved in the ozone layer depletion mechanism in the stratosphere. So the option number 3 is correct option friends. Next, number 10. The correct match between item 1 and item 2 is, the items compounds are given in item 1 and the reagents are given in item 2. What are the compounds? Lysine, furfural, benzyl alcohol, styrene. The reagents are 1-naphthol, ninhydrin, K-amino4, cetic ammonium nitrate. They have given different combinations. Let us see. Let us work on one by one. Lysine. What is the lysine? Yes friends, it is an amino acid. Amino acids gives ninhydrin test. Straight away choose this ninhydrin test. We know this. The options having AQ. This is not there, so 3 straight away goes out. Then furfural, what is the reagent? Furfural reacts with 1-naphthol. Benzyl alcohol, yes, gives reagent cetic ammonium nitrate. Just go for styrene. Yes friends, styrene reacts with K-amino4, the reagent where you can find styrene, right, because it oxidizes this styrene double bond to benzoic acid. So K-amino4 is the correct option. So styrene, Dr. What are the options? Dr. What about others? Yes friends, these straight away can be taken out, ruled out. Doesn't have any other options. Let us see the options. So lysine is ninhydrin. Next, furfural is 1-naphthol. That means B is P. So C is S. What is C? Benzyl alcohol is cetic ammonium nitrate. Yes friends, benzyl alcohol is cetic ammonium nitrate. That is how you can choose the correct option AQ, BP, CS and DR. This is how lysine is ninhydrin, furfural is 1-naphthol, benzyl alcohol cetic ammonium, that is CAN, styrene K-amino4. So the option number 1 is correct option friends. Next, number 11. An aromatic compound A having molecular formula C7H6O2 on treating with aqueous ammonia and heating forms compound B. Compound B on reaction with molecular bromine and potassium hydroxide provides compound C having molecular formula C6H7N. The structure of A is So what they are going to do, A upon reaction with ammonia is going to form B, and this B upon reaction with bromine and potassium hydroxide, they are getting C. What is the reagent? This is bromine and KOH. Yes friends, the reagent and reaction is known as bromine and KOH reaction is Hofmann's bromamide reaction. That means degradation will take place. So the how many number of carbons are there? C7. What about the product? Yes, C6. So there is a degradation. So to take place Hofmann degradation reaction, what is the starting material? Yes friends, amide. What we need? Amide. Some with ammonia we can get amide. So aldehydes will give imines. Aldehydes will give imines, whereas benzoic acid will give with ammonia. This amide upon reaction with bromine and KOH will give the required product. So that is how a compound, if we take benzoic acid, treat with ammonia and heat it, you will get amide, then bromine and KOH, that is Hofmann's bromamide reaction conditions. Rearrangement takes place and it produces this carbonyl group and gives aniline. Let us see the carbons. So the starting material C7H6, 1 2 3, this is 6 and 1 7, H6, yes, 5 plus 1 6, O2, these are the O2, C7H6 O2. Yes, starting material is correct friends. Next product C6, carbons are 6, yes, hydrogens are 5 plus 2 7 and nitrogen is 1. So C is matching and A is matching. So the option number 1 is correct option friends. Next question number 15, the major product of the following reaction is, what is the reaction? Sodium borohydrate reduction. It is a reducing agent. What it is? Sodium borohydrate is a reducing agent. What it reduces? It reduces carbonyl compounds to alcohols. Then what else? It reduces imines to amine, but it will not reduce alkenes or alkynes to alkanes. So the question is sodium borohydrate reduction of carbonyl compound, alkene and imine. Where it is going to work? It is going to work on alcohol. Yes, ketone to alcohol, this alcohol, this alcohol, this alcohol. Okay, fine. What about double bond? Double bond, will it going to reduce? No. So this is no, alcohol, but double bond is reduced here. So this option is not correct. Then next, what? Imines to amine. So double bond will be there, but imines to amine. That means option number 4. It reduces imine to amine and ketone to alcohol. Imines to amine? No friends. So this is also not correct. So the option number 4, that means sodium borohydrate reduces ketone to alcohol, imine to amine. So the option number 4 is correct option friends. Question number 18, which of the following tests cannot be used for identifying amino acids? Dear friends, amino acids identification test. What is the test? Just now we saw ninhydrin test. So they are asking cannot be used. Dear friends, again please follow these keywords. They are asking cannot be used. Yes, ninhydrin test can be used, but they are asking cannot be. Biuret test, yes, it is used for amino acids. Xanthoprotic test, yes, the test itself is showing protein. That means it is used for amino acids. So this is also not correct. Barfoed test, dear friends, Barfoed test cannot be used for identifying amino acids. It is used for to detect the presence of monosaccharides, to especially reducing sugars in solution. So the option number 2 is correct option friends. Next, question number 20, the major product obtained in the following reaction is, what is the reaction? They are using some base, sodium methoxide base, and heating, and the starting material is carbonyl compound, is having alpha hydrogens. There are carbonyl compounds having alpha hydrogens in presence of base under heating reaction conditions gives alkenes. What is this reaction? Aldol condensation reaction. Let us see what is the reactive positions. Yes, this is also one reactive position, alpha to carbonyl. This is alpha to carbonyl. This is also alpha to carbonyl. This is also alpha to carbonyl, and this is also alpha to carbonyl. There are 5 reactive centers. When compared to carbonyl and ester, which is more acidic, this will be the acidic. So this ester, alpha to ester is ruled out. So this is ruled out. Here it is not going to take place. Whereas this alpha to carbonyl compound, if this going to attack here, yes, there is chance 1 2 3 4 5 carbon chain, but inside the ring there will be strain of this carbon, there will be a strain of this, so this and this is not going to form. Is there any chance to form this alpha hydrogen? If it is taken, this is, so this side only one carbon, this is 3 carbon, so forming 3 carbon chain is very tough, so this is also not going to form. So 3 and here, is it going to form? It is also a 3-membered ring, it is very tough. Next remaining is 4. So this is a center where we can abstract the proton with sodium methoxide to give an ion. It is going to form an ion. It is going to form, here it is, there will be 2 hydrogens. It is very simple, friends. The 2 hydrogens, sodium methoxide will take out this hydrogen, right? So we'll take out this hydrogen and this bond moves here, it becomes minus ion. This minus ion goes here and attacks here to make it as alcohol. So CC bond formation takes place, there will be alcohol, and this hydrogen will be here, so there is no double bond now. When we heat this mixture, this loses water, minus H2O, then this gives double bond, this gives double bond, this gives minus water, this gives double bond compound. So the option number 4, friends. So the option number 4 is correct option, friends. The major product obtained in the following reaction, that is aldol reaction, we are going to cyclize these. So this carbonyl is here, this carbonyl is going to form double bond, and this ester is here, so this carbon is here. So the option number 4 is correct option, friends. Next, number 22. Which is the most suitable reagent for the following transformation? Let us see. 1, 2, 3, 4, 5, 6. 6 carbon to 1, 2, 3, 4, 5. So 1 carbon less, that means this is going to be cleaved, and alcohol is going to become acid. What is the transformation? Toleranz reagent? No, friends. Ammonical silver nitrate? No. Iodine sodium hydroxide? Yes. Iodoform? Let us see other reagents. Bromyl chloride? No. Alkaline KMnO4? No. This reaction, alkyl hydroxy compounds group gives a positive test with iodoform. This is iodine and sodium hydroxide by converting into acid group. So the option number 2 is correct option, friends. Next, question number 23. What is the IUPAC name of the following compound? Straight away they are asking, friends, IUPAC name of this compound. How many carbons are there? 1, 2, 3, 4, 5 and 6. 6 carbons are there. So as per IUPAC nomenclature rules, you have to choose the longest chain which is having high number of carbons. 1, 2, 3, 4, 5. Yes, friends. Let us see arbitrary numbering. 1, 2, 3, 4 and 5. 5 means it should be either the nomenclature should be pentene. Right. So the option number 1, butene, straight away strike off. Option number 2, propene, straight away strike off. Next, option number 3, 2-bromo 3-methyl pent-3-ene. Right, friends, 2-bromo 3-methyl pent-3-ene. So pent-3-ene. When there is a competition between substituents like this and alkene, always alkene gets more priority and it must be given least numbering. It must be given least numbering. So the numbering, if I start from here 1, 2, 3, this alkene is going to get 3 ene. Here it is given, but as per rules, IUPAC rules, the alkene group must get lowest number. That means this is the way we have to follow 1, 2, 3, 4. By following this 1, 2, 3, 4 method, we are going to get 4-bromo. Yes, this is a 4-bromo. 3-methyl, 3-methyl. This is a 3-methyl. 4-bromo, 3-methyl, and pent-2-ene. 4-bromo, 3-methyl, pent-2-ene. What is the position of alkene? 2 position. So pent-2-ene. Option number 4 is correct option, friends. So the compound nomenclature of IUPAC nomenclature of compound is 4-bromo 3-methyl pent-2-ene is correct option. Number 29. The major product of the following reaction is, what is the reaction? So they are doing the reaction with aqueous NaOH in first step, and second step they are treating with methyl aided. So this material, it is orthocresol. R is the phenol. Yes, sodium place. Yes. So this phenol will form a salt with sodium ion. Sodium ion. Sodium hydroxide is strong base, so with sodium hydroxide forms sodium phenoxide. Sodium phenoxide. This is sodium phenoxide, friends. It forms sodium phenoxide. This sodium phenoxide in presence of methyl iodide, what it will do? So what is this? Methyl iodine will take minus charge, partial minus charge. There will be a positive charge, and this is nothing but negative charge. This oxide ion will take up this methyl, and total there will be minus of sodium iodide. What is going to happen? Methylation of phenol. So methylation of phenol is taking place. Total reaction is methylation of phenol, that is methoxy group is forming. What is the option is showing? Methyl is intact, methoxy is here. What about other compounds? This is hydroxy is clear, methylation no, this is not going to take place. Ortho, para, meta, no, friends. If you do pre-Kirchhoff alkylation, then this is possible, but this is sodium hydroxide reaction. Here alkylation will not take place, here it takes place, that is methylation of hydroxy group. So the option number 2 is correct option, friends. Next, question number 30. What will be the major product in the following mononitration reaction? Mononitration reaction. What is going to happen? Nitrating mixture. Yes, friends, we are using nitrating mixture, sulfuric acid and nitric acid, and doing nitration of this benzoylate. This is benzoylate, this is aniline portion, this is benzoic acid amide, right? So this is benzoylate. Usually we do this aniline with acetylation product, that is acetyl group, but here they have given benzoylate, acetanilide. Instead of acetanilide they have given benzoylate, no problem. So when they are doing nitration, we know that benzoylate is orients nitro group to ortho para. So this is known. It orientation of nitro group will be ortho para. If it is instead of NH, if there is NO2 withdrawing group, what is the orientation? Yes, it should orient meta position. Meta dinitro compound will get meta position. So is there any option to go meta position? Is there any option? Nitro to meta. So the option which is having meta position of benzoylate is straight away you can strike off. It is not going to be the correct answer. Next, about this ortho and para, is there an ortho compound? There is no ortho compound. So para compound, is there any para compound? Para to, no, friends, this is not the correct answer. Benzoic acid, para, benzoic acid ring, it will not take place. So para to this, yes, this is the option. Option number 4, para nitro compound will be para nitro benzoylate. We will get para nitro benzoylate as a major compound. There will be some portion of ortho compound, there will be a mixture of ortho and para. So they did not given all those options. So the major product of this reaction, what we are going to get is para nitro benzoylate. So the option number 4 is correct option, friends. Thank you, friends. Thank you for watching this video. Please subscribe my channel if you are not yet subscribed, and don't forget to click on like button and bell button. All the best to your exam. Bye.